So last class we saw regarding the basic operation of our phasor diagram. So today we'll see one of the application how it is working in a bridge. So let's see. We'll see one of the most important bridge that is called Maxwell's inductance bridge. This Maxwell's inductance bridge is basically used to calculate the inductance or unknown inductance. So we'll see here, we'll see how to calculate or how this is my Maxwell's inductance bridge. So we'll see how to draw the phasor diagram. So see here this is the supply voltage V. Now when supply voltage V is flowing, this is having four arms, one, two, three, and four. So what is the relation we can see here? We can see that the bridge is under balanced condition when the current ID is equal to 0, and ID will be 0 when the condition VB will be equal to BC, or the voltage drop across AB is equal to the voltage drop across AC, or the voltage drop across BD is equal to voltage drop across CD. These conditions are the balanced condition for the bridge. So when this ID is equal to 0, I can say that my I1 is equal to I3 because ID is equal to 0. So you apply KCL at B. Similarly, our I2 is equal to I4. Now let and see this part. The voltage across branch 1 is V1, voltage across branch 3 is equal to V3, voltage across branch V2 is equal to V2, and voltage across branch 4 is V4. So you can take anything to be reference. Let's take uh, our anything. Let me take the voltage current I1 to be the reference. Let me take the current I1 to be the anything you can take I1, I2, B1, anything. Okay. So I1 is A. So we know that I1 is equal to I3. So I1 is equal to I3 same point. Right. So now say if I1 is this one, we hope the equation V1 is equal to I1 R1 plus J I1 omega L1. So V1 is the voltage drop across R1. This is R1 plus the voltage drop across the inductance. So now two things comes. One, the voltage drop across resistance, voltage drop across inductance. So we know the current. So what is the point here? We need to draw the voltage. So when you draw the voltage of the resistor, we know that last class we saw for the resistor, the phase angle between voltage and current is 0. And for the inductance, the phase angle between voltage and current is 90 degree. Right. So I1 is this one. So this will be my I1 into R1. Now, in inductance, we know that the current lags from the voltage by 90 degree. That means voltage leads. So I1 J I1 omega L1. So I1 R1 plus J I1 omega L1. This will be V1. Once you find V1, you know that this V1 is equal to V2, is not it? For the balance condition, V1 is equal to V2. Now, V2 is equal to my, what is the equation for V2? V2 is equal to I2 into R2 plus JI2 omega L2. So that means this is my, if this is my V1 equal to V2, that means what will happen? This is my I2 into R2 plus this will be same JI2 into omega L2. Now that means if this is my I2 into R2, that means this will be a line for I2, and this is the line for I2, and this is the line for I4. Right? Now here I3 is there, so I3 into R3 will be here, and we know V3 is equal to V4, that means I4 into R4 will be here. Now V1 plus V3, you take the resultant, you will get the supply voltage V. So what you need to understand here, you have to first derive the current values, next you derive the voltage and apply here. This is regarding your Maxwell's inductance bridge. Now we'll see the next topic of any other bridge.